Hello class, this is a video tutorial on trigonometric function graphing. So to understand completely the idea behind trig graphing, we need to learn the three initial and very basic trig graphs. So here's our sine wave, our sine graph, and the critical points are as listed here. And I hope you're familiar with them in terms of radians. Likewise, here it is for cos of x. And here are the critical points that we need to remember. And lastly, tan of x. And the critical points mainly here are the asymptotes at pi on 2, 3 pi on 2, 5 pi on 2, etc. Now, from these basic equations, we're going to look at graphing these following expressions here, these following graphs. We're going to do this by combining the general shape and critical points of trigonometric graphs along with our understanding of transformations, so we can easily understand the graphs of, it's a mouthful, f of x equals a sine of bx plus c plus k, and f of x equals a cos of bx plus c plus k. Also, we can still transfer these same knowledge from sine and cos to tan as well. But mainly, we'll be looking at sine and cos. So the first thing we need to learn is that the value of a affects what's known as the amplitude of the graph. The amplitude mainly states the highest and lowest values of f of x. So the orange graph here is the original sine x. Hope you can see it there. And notice that the highest and lowest values of those are 1 and -1. You can think of that as being the reason it's f of x equals 1 sine x. If we make it f of x sine 2x, notice how now the highest point is at 2, and likewise the lowest point is also at 2. And if we make it sine 3 of x, highest point is 3, lowest point is 3, and so on. K affects the baseline. I like to call it the baseline, but in mathematical terms, it's the average or the mean value. You can think of the baseline as the horizontal line the function cycles along. So if we have the original function, f of x equals cos of x, you can think of this as having a plus 0 attached to the end of it. And it's hard to see against the red line, the red axis. There is a line going along the middle here, y equals 0, that the function cycles up and down along. Okay. Now if we make it cos of x plus 2, well then that same baseline is the line that the function cycles up and down along. So it goes above that point, below that point, above that line, below that line, and so on. And likewise, we have f of x cos x minus, this is supposed to be 3, minus 3. And likewise, we have the baseline at y equals -3. So those two are easy enough to understand. Let's move on to what's known as the period. B in our equation here, this value of b, affects what's known as the period, the length it takes for the function to make a full cycle. So currently, let's take a look at this. F of x equals sine of x. With sine of x, there's a value of 1 in front of it. So if we take 2 pi on 1, as I've shown here, the period is going to be 2 pi. So what it means now is from 0 until 2 pi, the orange graph will go up, down, and then from this point here, the function is actually cycling itself again. It's repeating itself. So the period refers to how long it takes for the cycle to make one full cycle. If we have f of x equals sine 2x, the period is now 2 pi on 2. Those 2's cancel out, meaning it's pi. So the period now is that this is the function, sine, will finish between 0 and pi. Okay, so focusing on the black line now. So normally, the orange line, it goes up and down between 0 and 2 pi. But now it'll do that same cycle up and down, but this time it'll do it in the same scale between 0 and pi, then repeat itself again every distance of pi that it gets. Okay, so now if we have f of x equals sine half of x, or it can also be written as x over 2, the period is now going to be 2 pi divided by half, which is going to be 4 pi, meaning, watching that blue line, what took a distance of 2 pi going up and down once, it will now take from 0 to 4 pi the function to go up and down only once between 0 and 4 pi. So that is what the period does. An alternative way to think of this, B, is how many cycles will f of x complete between 0 and 2 pi. So if we had sine of 2x, that means it will have 2 cycles between 0 and pi. So 2 cycles, take a look. That's 1 cycle, 2 cycles. Whereas sine of x, there's a 1 here, it'll do only 1 cycle between 0 and 2 pi. And lastly, if we have sine of half of x, that means there'll be half a cycle, so it'll only get to go up and halfway down between 0 and 2 pi. Okay, let's move right along. C translates or shifts the entire graph left or right, as it normally does in a regular transformation. So take a look at the first line, f of x equals sine of x. So the regular graph is as shown here. We're used to this one. But now, if we do, watching the black line, plus pi on 4, that means the entire graph is moved across a distance of pi on 4 to the left. So what was once, if the peak was at pi on 2, we move it to the left by a quarter, so it's now going to be pi on 2. If this x-intercept was at pi, you move it to the left 1/4, so 1 minus a quarter, 3 pi on 4. This low point here is at 3 pi on 2, you move it to the left by the same distance. And lastly as well, the end of the cycle is at 2 pi, you move it to the left by the same distance. So every critical point is moved to the left by the distance of C. And I've got one more example here. F of x equals sine of x minus pi. Minus C means we move to the right a distance of pi. So take a look. Normally, we're observing the orange graph here. Normally, the orange starts, the sine starts on 0, but because it's been shifted to the right by pi, take a look at where this graph is now starting. It's starting at pi. Its first peak is at pi on 2. Because of that, it's been moved to the right a distance of pi to 3 pi on 2. So its first peak is now here. Its first intercept, so looking at the orange line, its first intercept is normally at pi, but that first intercept is now moved to 2 pi, looking at the blue line here. Its first intercept is there. Okay, so I hope you fully, well, not fully, but starting to see a pattern happening with the 3 different values of A, B, C, and K. This video is starting to get very long. Hope that gave you a quick insight. I'll do a few examples in the next video to come. Hope to see you in the next video. Best of luck.